So, what is the difference between the speed and velocity? What is mean by speed or what is mean by velocity? Here we discussing 2 points. So, when you say the speed which is basically the motion of body. So, any object or any body changes their position from one place to another place. So, their motion of that body, we can say that the speed. Here, the average speed, we can consider it, the average speed is basically nothing but the ratio of total distance covered, or you can say any object moving from one place to another place, whatever distance, total distance covered to, to, to cover this distance, total time required. So basically it is the ratio of total distance to total time required to cover this distance. So we can say that this average speed is nothing but the ratio of the object or any body required to move or change their position from one place to another place to cover this total distance to the total time required for that change or motion or changing their positions. So we can say that total distance, basically we can say that S divided by your T. S is nothing but again your distance and T is the time required for the object or a body changes their position from one place to another place. So this is your average speed. This term or this speed having the unit of meter per second, or this distance which is in a meter and this time which is in a second. So in a SI unit, the average speed or speed having the unit as a meter per second. Now you can consider again the unit speed. When you say the unit speed, if any body or object changes their position from one place to another place with unit distance, changes body their position as a unit distance, and to cover this distance or changing the body from one place to another place, this is your unit distance, and to cover this unit distance take the unit time. So your unit speed is nothing but the unit distance divided by, or is the ratio of unit distance divided by unit time. Similar to your unit speed, you can define your uniform speed. Uniform speed. When you say the speed is uniform, so if any body changes or travel the equal distance in an equal time interval, So any object or particle changes their position in for that equal distance to, for this cover this equal distance needed the equal time interval, then you can say that your object has the uniform speed. So you just consider a small example. If any particle changes their position from one place to, just consider and here we make 3 intervals. This is your end point, and any object from one position to at their end position required 12 seconds. This is your 3 meter. Just consider 1 meter, 2 meter and 3 meter. So object changes their position from 1A to 1 meter takes 4 seconds. For 1 to 2, this is equal distance. Here 1 meter, this is also 1 meter and this is also 1 meter. So object changes here from origin to 1 meter takes 4 seconds. Here also it takes 4 seconds. And for last lap, there also required 4 seconds. So we can see that for the equal distance, all the distances are equal. For that equal distances required, the object required for changing their position but equal time interval. Here, if you plot a graph of your uniform speed versus time, you get here your time and your y-axis at uniform speed. In our example, we see that in any object or any body changes their position from one place to another place, which is in equal distance. In equal distance, and for that equal distance needed or required an equal time interval. Equal time interval. So if you plot this graph, average uniform speed versus your time, you get a straight line graph. Here you can say A, here you can say B. And in this graph, the area under the curve from this overall graph, which is a straight line graph, and this area under the curve, this shaded region, gives the total distance travel by that body. So you get total distance travel by body or any object. So in that uniform graph, graph of uniform speed versus time, you get total distance. This area under the curve gives us total distance traveled by that body. In the average speed, the total distance covered by any body in a total time required. So there is, we can say that delta S by delta T. Total distance covered in a total time of that body. In an average speed, there is maybe a fastness or slowness. You can say fastness or slow. Any object changing their position or very fast, or it may be or very slow. These two terms arises. So if you consider again one small example, just consider any athletics taking the participants in a race. So this distance, we can say that from point A to point B, which is 100 meters. We are considering this distance is 100 meters. So athletics start from their starting point, ended at the point of B. So here we just considering their distance, which is 100 meters, and for that time, what is time required to cover this distance from A to B. But we are not considering how this athletics go very fast or very slow. Here in this example, during this motion, this fastness or the slowness of any object, or in this race athletics, their fastness and slowness, which is varying for the time instant, which it changes for the instant to instant. So we can see that when this athletics started from their starting point, their speed will be slow, but when outcome approaches to their end point, their speed gradually increases. At the end point, the speed of the athletics which gradually increases. So here we can see that the new term which is nothing but the instantaneous speed. In your average speed, we define that any object changes their position, their position or the time required to travel the total distance. V average, which is equal to total distance. The object changes their position from one place to another place, this total distance, and to cover this distance required the total time. So, your P average is equal to delta S divided by delta T. So, here we can see that in your instantaneous speed, or here in that case, we considering that your delta T is very small, which is vanishes to 0. This delta T vanishes or approaches to 0. Your delta S, this total distance, it becomes or it tends to 0. Here your delta T, your time required, this total time, if vanishes or its delta T tends to 0, then your distance also tends to 0. But this delta S by delta T, the ratio of delta S by delta T, which have some finite value, In your instantaneous speed, we can see that delta S by delta T is equal to, this ratio has some finite limit. So, this is finite limit. Now, we are considering your delta T approaches to 0. Similarly, if your delta T approaches to 0, your delta S also approaches or tends to 0. So, in your instantaneous speed, we are considering the limit of your function. So, your instantaneous speed, which is nothing but P, is equal to limit delta T tends to 0, your delta S divided by delta T. So, this limit delta T tends to 0, delta T divided by delta S, which is nothing but ds divided by dt. And here any object changes their position or changes the distance traveled any object with respect to your time or within that time. Here in this term, your instantaneous velocity ds by dt, this s is nothing but distance traveled in time t. Now this instantaneous speed in terms of your calculus, if you considering the calculus in terms of your calculus, so it is defined as instantaneous speed is nothing but the rate at which your particle changing their position. It is rate at which any particle changing their position with time, with respect to your time in a given time. Basically, it is the rate of change of your position with respect to time. So, in a calculus, we define your instantaneous speed. The average velocity of a body we can define as the total displacement. Basically, it is the ratio of total displacement with respect to total time required for that displacement. If you considering the delta x, the total displacement, this is the total displacement, and for that displacement required the time, which is delta t, and this average speed we can say that v average, which is equal to the ratio ratio of your delta x divided by delta t. So this average displacement velocity is nothing but the ratio of your total displacement divided by your time required, total time required for that displacement. So this displacement, this delta x is a vector quantity, vector. So your average velocity is also a vector quantity. Your delta x require your magnitude as well as direction. In our displacement we see that it is a vector quantity, and you know that the vector quantity having magnitude as well as direction. So this displacement is along the x direction. Here we considering this displacement is along the x component. So your displacement is along the x direction. So your average velocity, which is nothing but delta x by delta t, along the x direction. To check for this average velocity, again we consider a small example. Just consider any car or any motorcycle which is travel on the road. So considering this is your origin. Now here we can see that now from this origin your bike or motorcycle travel from this road. Initially we see that the rate at particular time t1 this motorcycle travel the distance x1 or time interval t1. At particular time t, or you can say that time t1 your motorcycle travel the distance x1. Again for time t2, considering for time t2 your bike is along the x direction, which is moving, changing their position from x1 to x2 for time t is equal to t2. So and this is along your x direction, or x, we can say that x component. So the average velocity along the x direction or x component, which is nothing but p average, which is equal to, we can say that the displacement, which is x2 minus x1, x2 minus x1 divided by this time required for this displacement, or your delta x. Delta x nothing but this is your delta x, which is x2 minus x1, and for that time t2 minus t1. So you get delta x divided by delta t. This is your the x component, average velocity along your x direction. Here the average velocity along the x direction is nothing but, we can say that I cap. So this term gives the magnitude, and this I cap gives the object moving along your x direction. So because earlier we say that your average velocity or your displacement is a vector quantity. So for to present their direction, this I represented the object is moving along your x component. Here we again consider a small example. Just consider this x1 is equal to 10 meters, and for to cover from 0 to your x1 it takes the time 2 seconds. t1 is equal to 2 seconds, and from this x1 the particle changing their position, or any bike changes their position from x1 to x2, your x2 is nothing but 35 meters. And to cover this distance, it takes t2, time t2, which is nothing but 7 seconds. So, from these values, we can calculate your average velocity. You know that C average is equal to your delta x divided by delta t, which is equal to, we can say that, x2 minus x1 divided by t2 minus t1. Here you know that x value of x1, value of x2, time t1 and time t2. Just put this value in your formula, you get 35 minus 10 divided by 7 minus 2. So you get 25 divided by 5, which is equal to 5, and unit is meter per second. So your average velocity you get 5 meter per second. Here you get the delta or your average velocity is positive value. Here in this example you get your average velocity is a positive value. It means that the object is moving, changing their displacement, changing their position along the positive direction. Along the positive direction. Or you can say that in a forward direction. In second example, if your average velocity or your particle is moving in a negative direction, then your average velocity will be negative. In first case we see your average velocity is positive, so in that case your object is moving in a forward direction or positive direction, or you can say that in the right direction. And here we have to see, just consider your bike or any vehicle is at position x1 is nothing but your 100 meter at time t1, which is nothing but 15 seconds. After the time interval changes from time t1 to t2, which is 30 seconds, the bike or any object changes to your position x2, which is 40 meter. So this different delta x is nothing but the displacement of object from x1 to x2. So your average velocity, which is equal to delta x by delta t, which is nothing but x2 minus x1 divided by t2 minus t1. So your x2 is nothing but 40 meter minus 100 meter divided by time 30 seconds minus 50. So it is nothing but minus 60 divided by 50. So you get minus 4 meter per second. So your average velocity, the value of this average velocity is, we get the negative value, you get a negative value, and this negative value defined as, or we say that your any object changes their position along the reverse direction or in the negative direction. If your average velocity is negative, then the object changing their position in a negative direction or a left side. We can say that simply a left side. In first case, which is at the right side or your positive direction, and if your average velocity is negative, in that case the object is changing their direction, changing their position in a negative x direction. From all these examples, we can say that there are some general cases. So first case we can say that if your position x is positive and which is increases with time. So we can see that this is your time axis or your x direction, and if your x value, position x value is a positive value and which is increases with time, or we can say that if your x is negative, your position vector or the position of your object which is negative and which is decreases become a less, or we can say that this x close approaches to your 0. So x is decreases with time, then your average velocity will be positive. In that case, your average velocity, the average is positive value and which is along your x direction, or it's along the positive direction, object moving to the right side. Object which is changing their position from one place to another place. Here average velocity is positive and your object which is moving in a forward direction, positive direction, or we can say to the right side. In your second case, if your x is positive value, in your second case x is positive value and which is decreases with time, or we can say that if your x is a negative value, again x is a negative value and which is again become a more negative, we can say that this negative value become a more negative. In that case, your average value, average velocity is negative. So in our second case, if your position vector is positive value and which is decreases with time, or it may be a negative value and which is again become a less negative or more negative, so that in that case your P average is a negative value and your object is moving a reverse direction or a negative direction, and or we can say that at the left side, object is moving to the left side. These are two simple general cases. Also, in an average velocity, if the displacement is 0, so object changing their position from this x to here and again become a return to its original position. So in that case, your displacement is 0. Your displacement or delta s become a 0 and your average velocity, so from this displacement is 0, it means your average velocity will be depends only on the starting and the end point. Exactly what happened in the intermediate or time interval, small instance, so we are not considering this part. This our average velocity will be depends on the start and end point. When this displacement is 0, so here this average velocity does not give any information. This average velocity at your displacement is 0, which does not give any information in between intermediates. How any object changes their position, how fast, how slow in that intermediate places only gives. So that's why I say that this average velocity gives the value, or which is only depends on your starting and end point, where from where it start and at where it is ended. So this is only for your average velocity. In our previous point, average velocity, we see that the average velocity is only depend on your endpoints. So it does not give the information in intervals or intermediates. So exactly in that positions, intermediates, what exactly happen, how object changes their positions, is it fast or it is slow. So in your average velocity does not give this type of information. So if you want to this information, we can see the instantaneous velocity. From this instantaneous velocity you get the fastness or slowness of the object changing their position, which is nothing but here displacement. How object displaced from one place to another, is it a fast or slow. So we are considering from that, we just consider a small time interval. We make a small time interval which is almost close to your zero. If we make the small time interval, your displacement also become a very small. So, but the ratio of your displacement by delta t or a t, small delta t, this ratio is not so small. Only your time interval delta t is small, and due to that time interval your displacement, we make the small parts which is also become a very small. This is along x-axis. So we just make the small time interval, your small delta t. So your time displacement, which is delta x, which is also become small. So here we are considering the limit. So as delta t approaches to 0, what happens? So by considering the limit, if you take the limit of your average, this ratio delta x by delta t, which is nothing but your velocity. So we are taking limit delta x, delta t tends to 0, which is nothing but delta x divided by delta t. This delta x by delta t, this ratio is not too small. So if you take the limit of delta t tends to 0 of your delta x by delta t, which gives the derivative of dx by dt. So your derivative of dx by dt, or you can say that the derivative of your displacement, with respect to time, or you can also say that the rate of change of your object or any particle changing their position with respect to time. Derivative gives basically the change in quantity. How any quantity changes, is it very slow or is it very fast? So we can say that this is the rate of change of your displacement over a time interval. So your instantaneous velocity, which is equal to dx by dt. So in our instantaneous velocity, just we define that it is a limit of delta t tends to 0, delta x by delta t. So this is the instantaneous velocity is limit delta t tends to 0, or limit of your average displacement over a time interval, or we can just define that it is the derivative or rate of change of your displacement over a time period. So if this motion or your displacement of that object is along a x component, which is along x component, then you can say that your instantaneous velocity is nothing but which is equal to your dx by dt, or you can write px, which is along the x direction, into unit vector I cap. So this I cap is defined that the motion of that particle is along the x direction. So, or you can also, in terms of your limit, you can write delta x bar by delta t, limit of delta x bar delta t tends to 0 divided by delta t into I cap is equal to your rate of change of displacement with respect to time. So we can write your derivative dx by dt into I cap. So again this I cap is give us the information about the direction, the motion of that body or a particle in which direction. So this I cap gives the motion of particle is along your x direction. This gives here your delta x by delta t, in that your delta t which approaches to 0, but in the previous point I already tell that this delta x, the ratio of this delta x by delta t which not become 0, because if your delta t approaches to 0, in the same manner your delta x also becomes very small or also approaches or tends to 0. So your numerator and denominator both are become small, or which is both are tends to 0. So this ratio does not go to the 0. And from this equation, from this instantaneous equation, we can determine the instantaneous velocity. Our instantaneous velocity by plotting the graph of your x component or your position component over or versus your time. So by taking the graph, by taking the slope of this graph, your position vector component and time, which gives us the your instantaneous velocity.